Have you ever really stopped to think about what's happening inside your camera? I mean, how does this little box manage to just freeze a moment in time? It feels like magic, right? Well, today we're going to pull back the curtain and unpack the amazing science behind it all. So yeah, that's the big question for us today. How in the world does a device that's basically just a light-proof container manage to grab a slice of the world with all its detail and color and hold on to it? It sounds kind of impossible, but you'll see it all comes down to one simple thing: controlling light. And look, if you were to crack open a modern camera, this is what you'd see. It's a crazy maze of glass, mirrors, wires, and sensors. It looks super intimidating, I get it. But don't worry, we're gonna break this whole thing down piece by piece into something that makes total sense. All right, let's start at square one. Before you get into all the fancy tech, a camera is, at its heart, just a box. It's a container that's built to catch and manage light. The simplest way to think about it, it's just a dark room with a tiny window. And this is the key. This is the one idea that connects a homemade pinhole camera to a $1,000 professional rig. The whole game, the entire point, is to gather light from a scene and project it perfectly onto a surface that can actually record it. Everything else is just about making that one idea better and better. So, how do we go from just a splash of light to a sharp, recognizable picture? Well, that's where the first hero of our story comes in, the lens. You can think of it as the camera's eye. The secret sauce for any lens is a cool physics principle called refraction. You see, when light rays travel through the air and then hit the curved glass of a lens, they actually bend. And the shape of that lens is designed with incredible precision to control exactly how those light rays bend. And this is the ultimate goal. A great lens takes all those scattered rays of light coming from one tiny point in your scene, and through refraction, it bends them all back so they meet up perfectly at a single point on the camera sensor. When it does that for every point of light in the scene, boom, you get a sharp, crystal clear image. Okay, so the lens has done its job. It's focused to the light, but before that light can actually be recorded, we have to be really picky about how much of it gets in and for how long. This is what photographers call exposure, and it's handled by two main gatekeepers. The first gatekeeper is all about time, and that's the shutter. Just like the slide says, shutter speed is literally how long the camera sensor is allowed to see the light. The second gatekeeper, by the way, is the aperture, which is basically the pupil of the camera's eye. It controls how much light gets through the lens. These two have to work together perfectly to get a good photo. I love this analogy from Earth magazine. It makes it so easy to picture. The shutter is just a curtain. You press the button, the curtain flies open, light floods in and hits the sensor, and then snap, the curtain closes. It's that simple. But how fast that curtain moves changes everything. And you can really see the creative power of that here. A really, really fast shutter, like 1/4000th of a second, can freeze a hummingbird's wings. But a slow shutter left open for seconds lets motion blur across the picture, turning car headlights into beautiful streaks of light. It's how photographers literally learn to paint with time. All right, let's follow the light to its final destination, the thing that actually records the picture. In pretty much every camera today, that's the digital image sensor. Think of it as the high-tech electronic version of old-school film. You know, for about a century, photography was all about chemistry. Light would hit a strip of film and trigger a chemical reaction. But today, it's all about electronics. Light hits the sensor, and the sensor turns that light energy into a digital signal, just a long stream of ones and zeros. So what is a digital sensor? Well, picture a giant checkerboard, but instead of 64 squares, it has millions of tiny little buckets. Each one of those buckets is called a photosite, and as light pours in from the lens, each photosite measures exactly how much light landed right there. And that one little measurement, that becomes one single pixel in your final photograph. So we've got the lens focusing, the shutter controlling time, and the sensor capturing everything. It sounds like a foolproof system, right? But we've all taken blurry photos. So let's talk about why the real world and the laws of physics can sometimes get in the way of that perfect shot. There are a bunch of usual suspects when it comes to blur. You've got the obvious ones, like if you move the camera or if your subject moves too fast, or maybe the camera's just focused on the background instead of your friend's face. But then there's the more technical stuff, like the physical imperfections of a lens itself, which are called aberrations. This is a classic one. It's called spherical aberration. The problem with a simple curved lens is that light rays hitting the edges don't focus on the exact same spot as the rays hitting the middle. And what does that give you? A slightly soft, kind of dreamy image. This is a huge reason why pro lenses are so expensive and complicated. They have extra pieces of glass inside just to correct for these little flaws. And if you want to see what a huge deal this is, look no further than the Hubble Space Telescope. No joke, when it was first launched, its main mirror had this exact problem, a tiny flaw that caused that blurry mess on the left. They actually had to send astronauts up to install corrective optics, basically to give the telescope a pair of glasses to get the mind-blowing images we see today on the right. Another common issue is distortion. This is where the physics of the lens literally bends what should be straight lines. You see it a lot with wide-angle lenses. It's just a little reminder that what the camera captures is always an interpretation of reality, shaped by the laws of physics. So let's just recap that whole journey one more time. Step 1, light enters the camera and is focused by the lens. Step 2, the amount of that light is controlled by the aperture and the shutter. Step 3, the sensor captures that focused light and turns it into electricity. And finally, step 4, the camera's little brain creates the digital photo we see. When you think about it, every single photograph you've ever taken is this amazing partnership. It's a blend of the fundamental laws of physics and some seriously brilliant engineering, all working together in harmony to freeze a fraction of a second, forever. So the next time you pick up a camera, just take a second to remember all of that incredible stuff happening inside that little dark box. You're not just pointing and shooting, you are literally sculpting with light. And now that you know how it all works, what are you going to see differently?